Howdy y'all, let's talk about the weather, specifically the wind. As we very well know, warm air is less dense than cold air, so warm air rises. This means that the air around the equator, which receives direct rays from the sun, rises into the atmosphere above the earth. This rising warm air moves towards the north and south poles, where the air gradually cools as it moves. Remember, it's receiving the sunlight at a greater and greater angle the closer it gets to the poles. As the angle gets greater, the air starts to cool. And as the air cools, it becomes denser because the air molecules move closer and closer together. The denser, cooler air sinks as it approaches the poles. Now, when the warm air around the equator rises, it leaves behind an area of low pressure. As you remember, air moves from areas of high pressure to areas of low pressure, so the warm air from the equator rises and moves towards the poles. Cooler air from the poles moves towards the equator to replace it. And as we know by now, when the air from the poles gets to the equator, it's going to get warmed up. It's going to rise, move back up towards the poles, get cooler again, sink back down towards the equator, and so on and so on. And this process goes on endlessly. The movement of the air that we just discussed would make us believe that the wind would only blow from the equator to the North Pole to the South Pole. In other words, we'd have winds that came always from the same direction. But we know the Earth is rotating, so we have to throw in the Coriolis effect. Trivia alert! The Earth is rotating at a speed of 160 miles a minute. The Earth's rotation breaks up these north-south winds into several large circular wind systems. These wind systems flow in an easterly or westerly direction. These winds are named for the direction from which they blow. Now about those winds. Starting at the poles, between 90 degrees and 60 degree latitude are the polar easterlies. I'm feeling a little bit of that right now. These winds flow from the east towards the west. In the areas between 60 degrees down to 30 degrees, we find the westerlies. Remember, the westerlies are responsible for bringing us our weather. In the area from 30 degrees down to the equator, we have the trade winds. Now they're blowing from the east, but they're not called easterlies. They are the trade winds. Remember, the sailors use them. Finally, we get to the equator. On the equator itself, since the air is mostly rising, the air is very calm, almost no wind, and afternoon rains. We call this area the doldrums. Sailors on sailing ships used to get very sad and depressed when they got to the equator because if there was no wind, they weren't moving. Today we even have an expression, somebody's down in the doldrums. It means they can be very sad. There is another very important type of wind that greatly affects our weather, particularly our winter weather, and it's the jet stream. There are two jet streams, one in the northern hemisphere and one in the southern hemisphere. These strong winds are in the upper troposphere, and they blow from the west towards the east. These things can go from anywhere from 80 kilometers per hour up to 600 kilometers per hour, and they can really speed up or slow down jets flying in them. The altitude and latitude of the jet streams changes with the seasons. In the winter, the jet stream is closer to the ground, and it moves closer to the equator than it does in the summer months. The jet stream is usually responsible whenever we get really cold weather down here. See, the jet stream is kind of like a fence. It separates the cold, dry air to the north from the warm, moist air to the south. So in the winter, if we have really cold weather, it's pushing our warm air away from us. And finally, let's not forget that we have something called land breezes and sea breezes. We've already learned that land heats up and cools off quicker than water. So during the day, land heats up pretty quick, causing the air to heat and rise. Now, the cooler ocean air comes in to replace this warm rising land air. Since the wind is coming in from the sea, we call it a sea breeze. During the night, the ocean's warmer than the land is. So as we know, water cools slower than land. So now the air over the ocean's the warmest. Air over the ocean rises, cool air from the land goes out to sea to replace it. Since the wind is coming from the land, we call it a land breeze. Never forget, winds are named for where they come from. Let's review that. These winds are caused by the differences in land temperature and water temperature, and their direction depends on whether it's day or night, and sometimes the weather conditions might affect it a little bit. Okay, now all this talk about the wind leads into a discussion about air masses. And there's a cold air mass moving in out here now, which is why it's so windy. Air masses are large bodies of air that covering either land or ocean areas. In the summertime down here in Georgia, we might have a huge hot air mass that covers part of Georgia, Alabama, and Florida. Now the characteristics of an air mass, such as the temperature and humidity, they're going to be pretty much the same within that air mass. Air masses also take on the characteristics of the areas over which they form. Let me repeat that. Air masses take on the characteristics of the area over which they form. So air masses forming over the land are called continental, and they have the letter small c. Those forming over the water are maritime. They have the letter M. Air masses forming at high, colder latitudes have the letter P, and those forming at lower, warmer latitudes are called tropical, and they have the letter T. Let's review that. C for continental, which gives us dry air. Maritime stands for ocean, gives us moist air. P stands for polar, which is going to give us cold air. And T for tropical, which is warm air. On a weather map, we would need to combine two letters to describe an air mass. So the symbol MT would represent a maritime tropical air mass. It would be moist because it formed over the water, and warm because it formed in the tropics. PM would give us polar maritime, which would be cold, moist air. Now when air moves into a new area, the temperature and the humidity of the area will change. The areas where these different temperature air masses meet, these are called fronts, and we're kind of in the frontal system area right now. There are three basic kinds of fronts: a warm front, a cold front, and an occluded front. And fronts are usually associated with bad weather, clouds, and precipitation. When a warm air mass meets or overtakes a cold mass, a warm front is formed. The warm air begins to rise above the cold air mass in a gentle slope. The first indication of a warm front may be cirrus clouds, those real light, thin, feathery clouds forming way up high in the sky. As the warm air rising begins to cool, thicker and lower clouds begin to move into the area. Warm fronts can bring extended periods of snow or rain falling from the nimbostratus clouds. Remember I told you nimbo stands for precipitation causing clouds. As the warm front passes, temperatures usually rise. Now when a cold air mass meets up with a warm air mass, a cold front is formed. The denser cold air pushes the warm air upwards rather quickly. The quickly rising warm air may form cumulus or cumulonimbus clouds. These clouds may bring shorter periods of rain or snow. As the cold front passes, winds usually get stronger and the temperatures will fall. I can tell you that's for sure. It's happening right now. You hear all the wind, and I'm getting kind of chilly. Cold fronts usually move quicker than warm fronts, sometimes twice as fast. And sometimes a cold front may actually run over the top of a warm front, actually mixing in with it. When these two fronts collide, they form an occluded front. Weather in an occluded front has some characteristics of both a warm and a cold front. You might have light rain or snow followed by periods of heavy thunderstorms and so forth. And on the weather map, remember, a low pressure is warm, it looks like those little red pillows, and a cold front, it's got the little teeth. As we look around and listen to the wind, we can easily see that I'm sitting out here in the middle of a cold front as it moves through our area. Yesterday it was warmer and it rained all day. That air was much less dense than the cold air mass that's moving in here today. The cold air mass is shoving that warm, wet air out of the way. Now, of course, over the next few days, the cold air is going to get warmed up by the earth and by all the sunshine we'll be getting. And who knows, in a few days we'll be getting some more rain. One thing we can depend on: the weather, it's always changing. And speaking of changing, I'm going to go find a jacket. It's getting chilly out here. See ya.